Hello, everybody. So we are continuing with law of cosines, and we're doing some application problems. So here we got three islands. You know the distances between each island, but you don't know exactly how they're orientated to the degree. And the situation is you're on island A, and you want to travel to island C. So what should be your bearing? And quick example with bearing, this is how we're gonna want the answer. N32E means you begin facing north, and then you rotate in an eastward direction 32 degrees. So heading off in this direction would be N32E. So starting off in island A, if we face due north, we need to figure out how many degrees do we need to rotate in this direction, which is to the east, to get to island C. So we're looking for this angle, which is outside of the triangle. So how do I do that? Well, if I could only find this angle, then I could do it because this is due north, this is due east, that forms a right triangle. And if I know this angle, I could just take 90 minus this angle and get the angle that I need for my bearing. So that's my plan. I'm going to find the angle right here. And I don't have any angles, so I can't do an angle and its opposite side. So law of sines is out. But I have side, 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 which means I could do law of cosines. And I want to be smart here. I want to have the cosine of this angle, which I'll call angle A. So I'm going to start with A squared, with 7 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of this angle. So replacing all those with numbers, simplifying this right here after this step, this is where students either get 100% right or they fall apart right here. This 60 is attached to the cosine, guys. So that's one term. And it is not a like term with 36 and 25. It cannot be combined. So you're just forced to subtract 25 and subtract 36. Do not combine these. They're not like terms. 36 minus 60, that shouldn't even enter your head, because I know if I gave you 36 minus 60x, none of you would subtract these two. None of you would. I believe that. So same thing here. This 60 is attached to cosine A. That's a variable. I don't know what that is. Might as well be x. And then I could divide by a negative 60. Great. I could divide by negative 60 and I get positive 0.2. Cosine inverse that. Go to my calculator and I discover that angle A is 78 degrees. That means this angle is 78 degrees. So this angle right here. So what's my bearing? Well, I have to remember this angle, which is just 90 minus 78. So it's 12 degrees. And my bearing is therefore north 12 degrees east. So 12 degrees east of north. Another example with application, this one seems kind of tough when we first look at it, but we've got this tower and the vertical height is 400, and I want to find the length of these two wires that are anchoring the tower to the ground. And what makes it more complicated is that it's on a slope, a 7-degree slope. But the wire is 80 feet away from the base of the tower on either end. So the whole picture is not a triangle, but you can kind of break it up into two separate triangles. And I'll call wire 1 just this wire over here, and wire 2 this one over here. And what do I know about these two triangles is that they both have a vertical leg of 400, and these two smaller legs are 80, and it's on a slope of 7 degrees. I don't know any angles right now. So how am I going to find this? I can't use SOHCAHTOA because I don't have a right triangle. What can I do? Well, here's the horizon, this green like the earth. And this angle right here, this is 7 degrees. Well, if I rotate this up, this is also 7 degrees from the green to the red. and then that's 7 degrees from the green to the red. Everywhere is 7 degrees. In fact, this one might be a little bit easier to work with first. I know that from the green to the red, that's 7 degrees, the 7-degree inclination. And look at the blue one now. The blue one to the green line, don't we see that that forms a right angle? The blue line is vertical, the tower is perfectly upright, and the green line is the horizon. So that's 90 degrees. Well, if this is rotated up 7 degrees, then this angle right here must be 83 degrees. And that's how you can think through this. That must be 83 degrees. We squeeze that in right there. And so let's figure out wire 2 first. I have a side, an angle, and a side. And so I'm going to do law of cosines. I can't do law of sines. I don't have any opposing relationships. I have this angle, but I don't know this side. I know this side, but I don't know this angle. And so I'm forced to do law of cosines. And then do the law of cosines that has this angle in it, cosine of 83. And it's going to be using these other two numbers. So W2 squared equals 400 squared plus 80 squared minus 2 times 400 times 80 times the cosine of 83. Now the good news about this is that look, here's the equal sign. Everything to the right of that equal sign, these are all just numbers. As opposed to this previous example, here you had a bunch of numbers and then a variable. But over here, these are all numbers. So you can just type this into your calculator straight away. And that's what I recommend you doing. I broke it up, but you can just type all this into your calculator, press enter, and you should get 158,600.362. That equals the second wire squared. So you square root it, and you get this. So the second wire, this distance, this length of a wire is 398.2 feet. What about wire 1? It's going to be longer than 398, but I just need that angle. Well, I hope you remember geometry, or maybe this is just this. Hopefully, this is maybe just intuitive. But here's a right angle again. This blue vertical and the green horizon. But what's this little angle down here? It is also 7 degrees. You can think of there's probably a whole massive chapter in geometry called two parallel lines cut by transversal. So you got these two green lines that are parallel, and this red transversal. Well, if this is 7 degrees right in there, then this is 7 degrees right in there, the alternate interior angles. Nevertheless, that's 7 degrees. So this angle right here is 90 plus 7. So it's 97 degrees. And you set it up. So first wire squared equals this section of the law of cosines. Put all into your calculator, press enter, you get 174,000. You square root that, you discover that wire 1 is 417.4 feet. And then area of a triangle, very quickly, we can find the area of a triangle. Of course, you all know it's half times base times height, but we can use SOHCAHTOA to get this shortcut. If we don't know the height, we can find this. The B sine C kind of finds the height for you. So half times A times B times sine C, or half times B times C times sine A, or half times A times C times sine B. And that may seem like a lot to remember, but let me try to make it very simple for you. What do all three of these have in common? Like, let's take angle C. Here's angle C, and the two sides you're using are the sides that are adjacent to C. That's the trick. Here's angle A. The two sides that are adjacent to angle A are B and C. So in angle A, you have B and C. And then with angle B, the two sides adjacent are C and A. And here's angle B, and here's A and C. So half times base times, okay, so A times B times sine of C, really just think of it as a side, an angle, and a side. If you ever have those three, if you ever have a side angle side, you can find the area of that triangle. It would be 1/2 times this side, times this side, times the sine of this angle. Let's just do one little example. You see how we have the relationship. We have side, angle, side. So I'm going to do 1/2 times 6 times 12 times the sine of 25, which is that. Popped up my calculator. I discovered that this triangle has an area of 15.2 units squared.